Hi all, this is Yuva. In this video, I'm going to present about my simplified midterm project implementation, where we are given with three tasks, where the first task is to deploy a pre-trained model from Lab 5.4. We need to deploy that model into AWS SageMaker as an API endpoint. And the second task is we need to create a Python client where it is going to take exe files as input, and it needs to extract the relevant features, and it needs to predict whether it is malware or benign, uh, and it needs to send back the prediction. The third task is we need to select 100 malware samples and 100 benign samples from the Ember data set. And we need to compare the performance with our model to the Ember's data set. Uh, let's check how I have implemented this project. Uh, for this, I have created a SageMaker notebook instance with the name of Midterm notebook. Uh, in it, uh, I have downloaded and extracted all the data provided in the lab 5.4 in it, and this is our training script. In the training script, I left in training script. um, it is pretty much same mostly. I have made changes at the end, and we are going to fetch and save some particular data in this one, and that includes like this one. Our model is saved as model.joblib file uh, for deployment use, and we are also saving our model, and we are also saving some other training data, like this imports featureizer and section names featureizer, since these are trained with training data, and we can't uh, train again for every API transaction we are making. So we are saving these models too. And and one more data we are going to use further is this K1 most common engrams list. This is we are going to use in the client file. We'll see how we are using this data in it later. Yeah. And this is our deployment script. In the script, first we are uh, writing out a uh, inference script, where this inference script is going to act as an executive ex server side script, where it is going to take a data and process our data and gives predictions to us. Let's check this code first. First, we are going to import all the needed libraries here. And this model function is going to load our model and returns our model. And we are following this particular naming convention for this functions is either SageMaker will identify and use these particular uh, functions with these following names. Uh, SageMaker is going to use the functions with these particular names. It identifies these functions and runs sends data to these functions. So that's why we are following this particular naming convention. And this particular input function is going to take the input coming to API and its format, and we are going to use JSON format uh, to send to the API. And this predict function will take that sent input data and model as inputs, and it will send this input data to process input function. In process input functions, what we are going to do is uh, we'll do some data conversions here. Later, we'll import our imports featureizer and section names featureizer training data. We'll load it and we'll use these models to transform this imports corpus and section names data here. Later, we'll extract the data and we'll return the data to the predict function. Later, the predict function will send this data to the model to predict the uh, outcome, to predict the type of the executable file we uploaded. And this predict function will return the predictions to the for output actually. In output, we'll take the prediction coming from the predict function and we'll extract its output and we'll send the data as in a JSON format uh, in this particular format. And this is our example representation of like how our data will look like when it's sent to the predict function here. Yeah. Later, we are writing a requirements.txt file. Why we are creating this? AWS SageMaker is not po posing the required libraries we have. Uh, if we are not going to mention our dependencies here as a requirements.txt file, it is not going to install and our endpoint will keep on gets failed without deploying. So I'm mentioning all the needed libraries here. And the note is uh, this for the scikit-learn, we are going to use the version 1.2.1 because AWS SageMaker have supports only this particular version. So we are training our initial training data also using this particular scikit-learn version only, or else the data will get the model we are storing will get mismatched there, and it won't support that particular model to deploy and gives out error to us. Uh, Later creating the requirements.txt file, we are zipping our models and scripts into a model.tar.zz file. We are saving all the models into in particular one particular folder path format like opt slash ml slash model since SageMaker is unable to using this particular path as default path, and it is not fetching any of the files that are outside of this particular path. And this is how we are going to our the file structure inside the model dot tar dot zz file look like. Let's go to check out deployment here. We are importing all the necessary libraries here. Later, we are establishing a uh, connection with the SageMaker using the Boto 3 library. We are creating a image URI here, a scikit-learn based image URI, where we are mentioning the framework is we are going to deploy a scikit-learn model, and the version we are going to use is 1.2.1 here. Later, we are uploading the R model zip file into S3 bucket, and in this part, we are creating our model. In this step, we are configuring the endpoint, and this particular code snippet will create a endpoint in SageMaker, and this particular code snippet uh, is going to monitor the deployment process for every 15 seconds. It will print creating status of the deployment. If it is still on creating, it will display creating until if it is successfully deployed, it will show in service and prints all the configuration of the deployed endpoint. Let's test out our endpoint here, whether it's working or not. We are going to send input data with this kind of JSON format here. And this, we are sending our content as a payload here. And this payload is sent to the endpoint, and we'll get a response uh, from the endpoint. Yeah, see, yeah, we are getting zero. Here, zero means like it is a benign. Uh, if it is one means it is a malware. So we are getting a proper output, right? So our deployment is successful and it is working perfectly. Let's check out the our client script for the yeah for the client script. These are the needed libraries. So we are first installing these libraries here. After installing all the dependencies, what we are going to do is we will fetch a IP address of our collab instance. Yeah, we got our IP address here. Later, we are going to write a invoke Python script where these are the needed libraries for that, and we are giving our ngrams as 2 here, and this is the all of the extraction script we have uh, used in the training part. So I have used the same code here to fetch all the needed headers from the exe file. So all the to extract all the features from the exe file. If you remember correctly, I have mentioned uh, we are going to use this particular list of most common engrams later in the client script. So here we are using that part. Yeah, what the script will do is it will start a Streamlit web application where it is going to take executable files. Let's start executing this one in the meantime. It will let's run this script. So it got deployed as a web application, and we can access that our Streamlit application using this particular link, and it is protected with the password. And the password is going to be the previous IP address we have fetched from the collab. Yeah, yeah. Here you can see the uh, this is our client actually to trigger the API where we need to input a exe file. So I'm inputting this 7Z installer as input. So it what it will happen is it will get uploaded, and this particular file is saved in a temporary path, and our script will fetch all the needed features from this one, and later it will show uh, and it will be trigger the AWS SageMaker endpoint, and the endpoint will process the received features, and it will send back the classification for us. So here you can see this is completely safe file. It don't have any virus in it. So it is we are written with a Benin and safe. If I delete this, it will clear that message from it. Let's import this with a virus file. Um, from the training data, I have extracted a one virus file. This is the only file my Windows system allowed me to store in my local. It is unable to detect this particular virus. I don't know why. Yeah, let's upload and check whether it is a malware or not. Yeah, you can see it is it sent back the classification as a malware and with a danger message. So we can say like our script is working really fine. Uh, and the third task is like we need to extract 100 malware samples and 100 Benin samples from the Ember data set, and we need to benchmark the performance. For that, I have developed a uh, Python script. What it is going to do is it is going to it will access the downloaded embedded set JSON file, and it will fetch out the first 1,000 samples from it, and it will extract these features from the each one, uh, where the byte entropy is going to be the n-gram features, and imports for the import corpus, and the section has a name, so it will fetch all the names in the section path. And this number of sections is going to count how many section names we have imported. And all this data is stored into a data frame, later saved as a CSV file. And this for loop will send out each row to the API, and recollects the response from the API, uh, and save the response into the same data frame, and save it as a CSV file, so that we can uh, check out the performance between the Ember dataset classification and R models performance. Uh, uh, yeah, that's it. If you need to refer any of the code, you can check out my GitHub profile, where the URL, where the project is named as Simplified Midterm Project. It has yeah, all of the codes I have used. Uh, Thank you.